Systems of equations. Let's get down to it. Alright guys, we're going to take a look at some examples of solving systems of equations. We're going to look at solutions, what they are, how we find them, how we know how many we have, and then we're going to look at two different methods for solving. First, we're going to look at substitution and then elimination. Okay, so what do we mean when we're talking about solutions? We're talking about the ordered pair, or the x and the y value, that makes both of these equations true. Another way to say this would be the point that falls on both of these lines. In most cases, the two lines are going to intersect at only one point, and that system will have exactly one solution, where the lines intersect. We might see parallel lines where the lines never touch, and that system would have no solutions. On the other hand, if the lines are on top of each other, and they touch everywhere, the system has an infinite number of solutions. Alright, now let's take a look at an example solving using the substitution method. The substitution method is especially useful when you already have one of the equations solved for either variable. So if you have an equation that looks like x equals something or y equals something. Otherwise, you'll first have to solve one of the equations. Then you're going to rewrite the other equation using the solved value. And I put value in quotes because it's not really a number value, it's more of an expression that represents that variable. Alright, so now let's take a look at an example. We're going to use an example where one of the equations is already solved for x. Our equations are going to be x equals 2y plus 3 and 3y equals x plus 1. Okay, so my next step is to rewrite the second equation, but instead of using the x variable, I'm going to use that expression up top because I know that that's equal to x. So my second equation, now rewritten with that expression instead of x, is going to look like 3y equals 2y plus 3 plus 1. Okay, now I'm just rewriting this thing without the parentheses to show you that those parentheses just show separation. Alright, now we're going to solve this just like we would any other equation. We're going to combine like terms first, so I add the 3 and the 1 to give me a 4. Now my next step is to get rid of the 2y, right? I want all the variables on one side, so I'm going to subtract 2y from both sides, and I end up with y equals 4. So now that we've solved for y, we can take that y value and plug it into either equation and then solve for x just like we would any other equation. So we're going to use the first equation, x equals 2y plus 3, and we're going to substitute our value of 4 instead of the y. So our rewritten equation will look like this. X equals 2 times 4 plus 3. Then we're just left with a few short steps to solve. We first have to do that multiplication. 2 times 4 is 8 plus 3, and we're left with x equals 11. Now that we have our x value and we have our y value, we know that the system has exactly one solution, and that solution is our x value of 11, comma, our y value of 4. Alright, now let's take a look at another example using the elimination method. So when we're using the elimination method, what we're really trying to do is eliminate one of the variables by having our equations end up with opposite variable terms. In other words, the variable terms will make a zero pair. It'll make more sense when we see our example, but we want something like a 2x in one of our equations and a negative 2x in the other. Once we have our equations set up the way we want, then we add them together. Okay, so now let's take a look at our example. For this one, we have 2x plus 3y equals 7, and our second equation, negative 2x plus 2y equals 8. Now you can see here I have the 2x in the first equation, negative 2x in the second. When I add those together, I'm going to end up with 0, and that's exactly what we're looking for. Okay, so now we can go ahead and add these two equations together. So we're going to have 2x plus negative 2x, which gives us 0x. 3y and 2y makes 5y. 7 and 8 gives us 15. But we don't really care about the 0x. We're just going to call that 0, so we can just go ahead and get rid of it. Then all that's left to do is solve for y. Do that by dividing by 5 on both sides, and we end up with y equals 3. Now all that's left to do is substitute our y value back into that first equation. Instead of y, we're going to use the value 3. So our new equation is going to look like 2x plus 3 times 3 equals 7. Then we're going to go ahead and solve. I have 2x plus 3 times 3 is 9 equals 7. We subtract 9 from both sides, and we end up with 2x equals negative 2. Last step, divide out that 2, and we're left with x equals negative 1. Now I have an x value, I have a y value. That tells us we have one solution, and that solution is the ordered pair negative 1, comma, 3. Alright, let's take a quick look at an example of how we might end up with no solution. So when we have a system of equations that look pretty similar but not exactly the same, that should set off our alarm. So the first thing we're going to do, since these are already solved, is we're going to use the substitution method. So what we're going to do is we're going to take the expression from the bottom equation that tells us that stuff is equal to y, and we're going to substitute it into the first equation where we see a y. So my new rewritten equation looks like 2x plus 4 equals 2x plus 3. Now I'm going to solve these by getting the variables on one side and the constants on the other. So my first step is to subtract 2x from both sides. And when we do that, we're left with a 4 on the left side and a 3 on the other side. 4 equals 3. Hold on, we got to ask ourselves now, is this true? Hopefully we all say no. That tells us that we have no solution to this system of equations. Alright, finally let's take a look at an example where we might see a system of equations with an infinite number of solutions. So one thing that we're really going to be looking for here is when these equations look very, very similar, so much so that they actually look the same. So how can we solve this? Well, we're going to use the elimination method. It might not be obvious, but if we multiply this bottom equation by a negative 1, then all of our signs are going to flip, and we'll have a 0 pair with that 2x, and we'll have a 0 pair with that negative 3, and we'll have a 0 pair with that 4. So once we distribute that negative 1, our new equation looks like negative 2x minus 3y equals negative 4. Bring our other equation down, and we're just going to add these two guys together. Negative 2x plus a positive 2x gives me a 0x, but we're just going to call it 0. Negative 3y plus 3y gives us 0y, but again, we're just going to call it 0. And then negative 4 plus 4 also gives us 0. So now we have to ask ourselves, is this true? Yes, of course it is. 0 is equal to 0. That tells us that this is a system of equation with an infinite number of solutions. But what it really tells us is that these two equations represent the exact same line. They are on top of each other. They intersect everywhere, forever and ever. Hey guys, remember, if this video is a little too fast or a little too slow for you, you can always adjust the speed in the playback speed settings. Have fun. Gotta go.